Oh, it's not May 13th, but this is what we were supposed to cover today. So I apologize for that, so let's restart. Chapter 1, displaying the order in a group of numbers using tables and graphs. The reason we do this is because once we get to the mean next time, you're going to see that in order to understand the mean, you need summation, which is what we did last time. You need frequency distributions, which is what we're doing right now. So what we're correctly doing at this time is we're going to take a look at descriptive versus inferential statistics, just a real quick explanation of what we're doing in the first part of this course so that we can do stuff in the second part of the course. We're going to introduce the idea of frequency distributions, we're going to take a look at frequency tables, and then we're going to take a look at frequency graphs or histograms, and I'll mention about your homework assignment coming up for chapter 1. All right, so once again, we're putting in the practice. This is basic statistical stuff so that we can do the cool stuff, but remember, this is a program that is designed but requires practice. So definitely do not skimp on any of the practice. Do your Excel sheets. Get quick with Excel. Get things automatic so that when we chain them all together, you don't have to think step by step, but much like Daniel when Mr. Miyagi let him have it, everything just comes naturally. All right, so one of the actual growing segments of psychologists that is going to have a lot of demand in the coming decades is actually sports psychologists. So if you were wondering what area of psychology to go into that might be the most likely to be a good job market for you, sports psychologists have actually been identified as one of the areas where there's a growing demand. So let's say that you go into sports psychology and you start studying the effects of getting involved in competitive sports. So let's say that you are specifically studying the effects of playing basketball. So what are the benefits of actually competing in organized competitive sports? So to do this, you would need both descriptive statistics and inferential statistics. So descriptive statistics, these are the statistical procedures, concepts, ideas that we have that are used to summarize, organize, and simplify data. So that example that I gave about the mean, where you take 100,000 numbers and you boil them down to one number so the governor of Indiana can understand and make sense of the situation, that's an example of descriptive statistics. So if you were doing your study on the effects of playing organized sports, you might interview and study that particular individual who's in a house league for basketball. You might interview and study this college player. You might interview and study this high school player. And you might interview this person in a recreational league who's waiting for their turn to play. You would interview hundreds of different subjects. You would have tons of raw scores. But in order to make sense of it all, you need to take all of those raw scores and simplify them and somehow get them down to, oftentimes, a single number, something that can be understood by the human brain. So that's descriptive statistics, taking a whole bunch of data and simplifying it, organizing it, so that we can understand it. And in the first part of this class, we're going to be mostly focused on descriptive statistics, ways of organizing data, such as the frequency distributions that we're going to see in just a moment. Now, the other half of the course, the second half of the course, is going to be inferential statistics. And inferential statistics is what allows you to study a sample and then generalize to something about a population. And the key here is that you get to study a sample and intelligently, unbiasedly, responsibly, and ethically generalize to a population. So we don't want to generalize incorrectly. I'll give you an example of generalizations that are done incorrectly. Just about all racism is a generalization that is done incorrectly. You see one instance of a behavior, and you generalize that to an entire race. Humans are very susceptible to that, right? You don't have to teach somebody to be racist. They will make those generalizations on their own. You have to teach them to be racist in a certain way, but they will naturally just make generalizations about individuals. We are very prone to going from subjects to the general population. That's what inferential statistics helps us do. It helps us take out that human bias and say, all right, what do we know about this sample? Are we allowed to generalize it to the population, or are we not allowed to generalize that to the population? So inferential statistics is going from that descriptive score, that simplified score, and then instead of just saying something about these 4 individuals that we have data about, it allows us to say something about everybody that plays basketball, everybody in a particular population. And inferential statistics is basically what allows psychology to happen. It's basically what allows us to study a sample of 20 subjects and then go out and help hundreds of thousands of people. Without inferential statistics, psychology would just be for those 20 subjects. Psychology would just be for the very, very rich that could afford personal psychologists. With inferential statistics, psychology is for everybody, and everybody can partake. So that's what our end goal is, inferential statistics. But first, we need to develop some descriptive statistics, the first one being frequency distributions. So frequency distribution, here's an example right here. It is an ordering of your raw scores. So it's an ordering of the number of individuals that have a raw score on a particular variable. So in this case over here, instead of just a jumble of numbers that we have in our raw data, we order it. So you can see that in this case we have scores on a test that's out of 100. This is a hypothetical distribution of scores. And what we've done is we've ordered the scores. So you can see 0 to 9 is here, 10 to 19, 20 to 29. So it's increasing in increasing order. And then what we've done is we have indicated how many individuals achieved a particular score by the height of these bars here. So this frequency distribution gives us that frequency, how many people attained this particular score, and this is in graphic form. So it's a way of organizing data. It's a lot easier to make sense of this graph once you know how to correctly read it. And it's a descriptive statistic procedure that allows us to summarize all this information. All right, so now that we have this in order, what we can see is, or one way to think about this, is to think about a frequency distribution. I like to use the metaphor of the apartment buildings. So imagine these bars as apartment buildings, and imagine that each floor contains one individual. So in this building right here, we got a 2-story apartment building, and 2 individuals are living in that room. 2 people scored between 50 to 59. In the apartment located at 60 to 69, we got 1, 2, 3, 4, 5 people are living. 5 people achieved the score of 60 to 69. 70 to 79, we got 1, 2, 3, 4 people. So again, the frequency here is how many people, height of the bar, you can see 4 individuals, 1, 2, 3, 4 people attained a score of 70 to 79. We got another 1, 2, 3, 4, 5 people attained a score of 80 to 89. And then we have 1 individual living in 90 to 100 land. They achieved the score between 90 and 100. Importantly, nobody achieved the score of 40 to 49, 30 to 39, or any of the lower scores. And you can instantly read that off of this frequency graph. So if this was just a jumble of scores, as it is when you first collect your data, it's hard to make sense of what's going on. But in a frequency graph like this, you can immediately see that a lot of individuals scored 60 to 69. We have only 1 person that scored 90 to 100. It helps you get a grip on the data a lot easier and to see the picture a lot clearer. All right, so that's what a frequency distribution is, and there's a number of different ways to structure this, to communicate this. And typically the two ways that are done is either in a table form or in a graph form. So you either put it in a table or you put it in a graph, a picture like this. They have their pros and cons. Graphs are a little bit easier to get the overall picture very quickly. I like graphs. Tables are a little bit easier to work with numerically. Some people prefer tables. It's important to know both of them. So let's take a look first at frequency tables. All right, so let's consider the following set of 20 scores. So that capital N and small n, what they mean is the number of scores that you have. So when you see n equals 20, that means that you have 20 scores. So if you were to count up all of these scores, you would count them all up and they would be 20 individual scores. So let's say that we have the following set of 20 scores on a 10-point quiz, and we have that jumble of information there. We're going to construct a frequency table of these scores so that we can organize this information. So a frequency table has two columns, and it is very, very important to be careful about that first column. So that first column is labeled X. That first column is labeled X, and that typically stands for the scores. So if you remember last time I told you read X, not as X, read it as the scores. So it typically stands for the scores, except in this instance. When it's in a frequency table, read it as the possible scores. So in a frequency table, it's not the actual scores, it's the possible scores. So that's going to help you not make a mistake that I'll point out in just a little bit once we get familiar with it. But read this as the possible scores. And then F over here, this is the second column, that is frequency. So read F as frequency. That's the frequency part of the frequency table. All right, so in the X column here, in the possible scores, this is where you list every single possible score that a person could have achieved on this quiz. So this quiz was out of 10. So a subject could have achieved a score of 10. That's a possible score. They could have achieved a 9 out of 10. That's a possible score. 8 is a possible score. 7 is a possible score. 6, 5, 4, 3, 2, 1. Even 0 is a possible score. So they need to be listed in this column. That is a column of possible scores. Yep?
Does it have to go high to low? Does it matter?
It has to be in order. Yep. So it typically goes from high to low. It could, I think, go from low to high, but it definitely has to be in order when you do a frequency table. Mm-hmm. All right. So we have the possible scores in order. And then what we do is we fill in that frequency column by counting up how many of those scores actually occurred. So this is the possible score. Here we count up how many times did that score actually occur in our set of 20 scores. So what we do is we'll zoom in on those scores. And what we do is we just scan them. And we take a look for this first score here as 0. So we scan it, scan it, scan it, scan it, scan it, scan it. Turns out nobody got a 0. So we enter in the frequency of zeros is 0. Nobody got 0 out of 10. We do the same thing for a score of 1, and we find out that the frequency with which 1 occurred is 0 as well. Nobody scored 1 out of 10. And then we continue to do this for every single possible score. So for a score of 2 out of 10, we got that score right there. We got that score right there. We have 2 individuals that scored 2 out of 10. So across from the 2 in that row, we put a frequency of 2. 2 people got 2 out of 10. We do the same thing for 3 out of 10. We have 1 right there. We got a second one right there. 2 people got 3 out of 10. We put that in the frequency column here for 3 out of 10. Do the same thing for 4 out of 10. We got 1 individual, 2 individuals got 4 out of 10. we put a frequency of 2 in the 4 out of 10 column. 5 out of 10, we got 2 individuals got 5 out of 10. Pop that into the row for a possible score of 5. We got 2 individuals who achieved a score of 5. For 6, we only have 1. One person got 6 out of 10, so that's a frequency of 1 right there. For 7, we have 1, 2, 3, 4 individuals achieved 7 out of 10. So the frequency in that row is 4, indicating that 4 people got 7 out of 10. For a score of 8, we have 3 individuals that achieved an 8 out of 10. So you see I almost missed one of the 8 out of 10s, but in a frequency table, it would be really easy. If somebody asked how many people got 8 out of 10, I'd say, well, the frequency was 3. So you can see the benefits of that frequency table. For 9 out of 10, we only have the 1 individual. And then finally, for 10 out of 10, for a perfect score, we have 1, 2, 3 individuals that achieved 10 out of 10. So we put the frequency there of 3, indicating that 3 individuals got 10 out of 10. When you're doing a frequency table, oftentimes you want to check, make sure that you didn't miss anybody. Check to make sure that you didn't miss any scores. So one way to do that is to sum up your frequency column here. So if you use the summation on your counts here, does anybody know what this number should be? It should be 20. So I heard 20. It should be 20. It should be the number of scores that you had. So if you start off with 20 scores and you do your frequency table correctly, everybody's going to end up somewhere in the possible scores. You should have a sum of your frequencies that's the same as your particular table. So this is one of the things that you use a frequency table for, is that it's a lot easier to deal with the data. It's a lot easier to answer questions about the data. So for example, let's say that I gave an award. Let's say that these were students in a class, and I gave an award to everybody that achieved 8 or higher on this particular test. With the data here, in this jumbled form, I would have to go and count. I would have to say, well, there's 1, there's 2, there's 3, there's 4, there's 5. I'd have to count through the entire data set in order to answer that question, how many students achieved a score of 8 or higher. If I have it in this frequency table form over here, I can simply go, all right, 3 individuals scored 8, 1 individual scored 9, 3 individuals scored 10, that's 7. I got 7 students that are going to achieve that particular prize. If I required students that scored 6 or lower to attend tutoring, an after-school tutoring session, how many students should I prepare for? How many students are going to be there? Once again, if I have to go through this, it's going to be slow, it's going to be tedious, it's going to be difficult to do. But if I go to the frequency table, then I can see here that we have 1 individual that scored 6, 2 that scored 5, 2 that scored 4, 2 that scored 3, 2 that scored 2, so that's 2, 4, 6, 8, 9 individuals. 9 people should show up to tutoring. So it makes it very easy to deal with these types of questions. It makes it very easy to access and be able to interpret your data. Now, I'm going to show you the one error that often occurs when using frequency tables, and it's an error that is potentially going to be made very, very often because it's something that is very typical to ask for. So as I mentioned last time when we looked at summing scores happens all the time. In statistics, oftentimes your first move is you take all the scores and you just add them all up. So sometimes you're going to get your scores not in this jumbled up raw form, but you're going to get them in a frequency table like this. Somebody's going to hand you a frequency table and say, here are the scores. These are the scores that you're working with. And they might ask you to sum those scores. What's the sum of the scores? And this is where it's very important to remember that this is the scores, but this is the possible scores. And the error that is made the most often by students is that they'll get confused and they'll see an X over here and they'll see an X up there, and for some reason, maybe just to get the question over with, maybe just to do something, they'll say, all right, well, there's an X, I gotta sum the X's, I gotta sum the scores. All right, so I'm gonna take the 10 plus 9 plus 8 plus 7 plus 6 plus wrong. That's not what they're asking you. This is the sum of the possible scores, not the sum of the actual scores. So the sum of the actual scores would be the 8 plus 5 plus 3 plus 2 plus 8 plus 7 plus 4 plus 8. It's the sum of the actual scores. So the first way to avoid this problem is to make sure that whenever you're dealing with a table, whenever you're dealing with that frequency table, as soon as you see that X up top there on the column, don't read it as the scores, read it as the possible scores. All right, so the frequency table is possible scores. And then the second thing to do is you need to unpack this from the frequency table. So if you're ever asked to do a sum of scores, and you will, because again, it is something that occurs over and over and over again. So if you are ever asked to do a sum of scores after being provided with a frequency table, the way that you do it is you start with, let's say, the largest score. You start at the top of the table and you say, there it is, how many 10s do I have? I have 3. So I'm going to unpack it. I'm going to go 10 plus 10 plus 10. That's the end of the 10s. How many 9s do I have? I got 1 plus 9. How many 8s do I have? I have 3 plus 8 plus 8 plus 8. So you have to unpack it using the frequencies in the table so that you can sum up the actual scores and not sum up the possible scores. All right, so you will see this. You will see this type of a question in your homework. You will see this type of a question on the exam. Make sure that you are summing up what needs to be summed up. So when they ask for the sum of the scores, they're not saying just sum this column. And in Excel, it's very, very tempting to do that because you know how to do it. Just sum equals sum and put in your scores. Make sure you don't fall for that because it's not, it's something that's going to happen over and over and over again. You'll have a frequency table, somebody will ask you for the sum of the scores. Make sure you're doing that correctly. Any questions about that or about this move right here? All right. So sometimes you have frequency tables and you'll often see them with the raw frequencies. Sometimes those frequencies get really big and then people convert it to a percentage. So it's fine when you're dealing with frequencies like these numbers here. But if you get into the thousands, it starts to get a little bit confusing. So sometimes people will convert these to percentages instead. And the formula that they'll use is percent equals frequency divided by the number of scores, all that multiplied by 100. So we got frequency, which is whatever the frequency value is for a particular score, divided by the number of scores, which is this 20 up here, all multiplied by 10, and then we can see that there is 15% of the scores are 10s, so 10s account for 15% of the scores, and if we calculate that all the way down, we'll get the percentage for each possible score, and once again, you can check percents by just summing them. It should add up to 100. Occasionally, if you're rounding, you'll get like 99 or maybe 101. But definitely if you're off by more than 3%, something went wrong. But you can also put it in percentages rather than frequencies. And that's usually done when the frequencies are large numbers. All right, so that is the frequency table. Any questions on that before we move to graphs? Okay. So that's frequency tables. You can also, and we've already seen this example here, show your frequencies in graph form as well. So you can, we'll take the exact same data, and your frequency graphs can be constructed as either a histogram or a bar graph. There's virtually no difference between the two. I'll just mention what it is when we get to bar graphs. But a histogram is the graphical form of this information. So there is that information in histogram form. So again, table, possible scores, here are the frequencies in your histogram, possible scores, here are your frequencies here, and you can see that it's exactly the same as that particular table. So once again, we have this apartment building that different individuals are living in based on the score that they achieved. And it's very easy to see that nobody achieved a score of 0 out of 10, nobody achieved a score of 1 out of 10. 2 people, the height of the bar, 1, 2. 2 individuals got 2 out of 10, 1, 2. 2 individuals got 3 out of 10, 1, 2. 2 individuals got 4 out of 10, 1, 2, 3, 4. 4 individuals got 7 out of 10, 3 individuals got 8 out of 10, and so on. So with a frequency distribution graph, it's a lot easier to get a picture, a general idea of what's going on in your distribution. So for example, it is quite clear from this frequency distribution that we have, in this case, if this was scores in the classroom, I have 2 distinct sets of students. I have one set of students here from 7 to 10 that clearly understand the material, they're doing pretty well. I have another set of students that are separate, that are doing not so well. So it's not that I have a nice kind of even distribution or anything like that. I have 2 sets of students. As an educator, that would indicate to me that my message is reaching half of the students very, very well, but something is going on with the other half. So maybe I have to bring in a second strategy to try to reach these individuals. Maybe I have to have different ideas to reach them, because clearly there's 2 separate types of students in this particular class. So it's important to be able to work with histograms as you do with tables. And once again, it's important to remember what a histogram is actually showing you. So if somebody was to ask a question about your distribution, such as what is the most common score? What was the most typical or common score in your distribution? It's very easy to take a look at this histogram and say, well, the most common score is going to be the one with the highest frequency. It's going to be the one with the tallest bar. That's a 7. So histograms have certain benefits compared to tables, but you need to be able to work with both. So once again, if I was to ask, what is the sum of the scores? Here's a histogram of the scores. What's the sum of the scores? Make sure that, once again, you just don't take a look at where an X is and start grabbing stuff and going 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6. That's the incorrect way to do it. It's not the sum of the possible scores, it's the sum of the actual scores. So in that case, you would have to go to the bars here and you would have to say, how many 10s are there? 1, 2, 3, 1, 2, 3. How many 9s? Just a 1. Just 1 right there. How many 8s? 1, 2, 3. 1, 2, 3. You have to unpack the histogram sometimes to do certain operations on that information. All right, so that is the histogram. And then the last version that you'll see is called a bar graph as well. And the bar graph looks like this for this particular data. And the only difference between a histogram and a bar graph is what type of data they're supposed to be used for. So a bar graph is intended for data that's known as discrete. That's data that you can't score in between values on. A histogram is meant for data that is continuous. That's data where you can score in between scores on. So for example, if you were doing a histogram of heights, in our university. If you just went and measured everybody's height in the university, that should be on a histogram. Because somebody could be 5'3", somebody could be 6'1", somebody could be 6'1½", right? Somebody could be 6'1¾", right? You can be in a continuous amount, you could have a continuous amount of height that should be portrayed on a histogram. On the other hand, if you were portraying how many courses have you completed in your major, right? So how many courses have you completed in your major? That is discontinuous, right? That's discrete. So you can't complete 1.5 courses, right? You either have 1 course completed, or 2 courses completed, or 3 courses completed. You can't do 2.25 courses. So that would be made in this bar graph here to show that you can't have those in between values. That's a very kind of nitpicky thing that's not going to come up again in this course. I just wanted you guys to know that in case you're wondering why do we have bar graphs and histograms. They're dealt with exactly the same. So you can imagine this as an apartment building in a rather close-knit community where they don't mind living next to each other. You can imagine this as an apartment building in a rather not close-knit community where they don't want to share walls with their neighbors. So it's still 2 individuals living in this apartment building here, but it's just that there's nobody living in between. All right, so that was what I wanted to cover for today. Any questions on anything so far? Okay, so before we wrap it up and turn it over to practice time, I just want to mention a couple of things. Number one, the MyStat Lab study plan quiz me option to earn your mastery points. I put up a link in an announcement on that. Sometimes in the past I found that students didn't know how to find the mastery points or how to earn them. So this is just a quick little video, it's like 3 minutes long, that just kind of takes you through how to access those, where to find those. Those are going to become much more important as you start getting your feedback for your pretest. So for example, I believe the first pretest was due at midnight yesterday. So you got your feedback for your first pretest. If you got 100%, great, awesome, way to go, keep up on it. If you didn't get 100%, you still get value from doing the pretest. But I don't want it to necessarily impact your grade, right? I don't want you to view the pretest as a hindrance to your ability to do well in this course. It's not what they're meant for. So if you go and check your pretest score, and let's say that you got 50%, what you can do is you can go to the Chapter 1 Quiz Me study plan. Sorry, you can go to the Chapter 1 study plan, and they have mastery points available. Some chapters have 3 mastery points, some have less, some have more. And if you earn 100% on the mastery points, like you get 3 out of 3 mastery points, I will bump your pretest score to whatever your mastery points are. So if you get 50% on your pretest, but you get 100% on your mastery points, I will correct your pretest score to be 100%. So your score is going to be the maximum of your pretest or your mastery points. So it's a nice way to have that fallback option, but definitely watch the video if you're at all confused about how to earn those mastery points. There's the practice problems that come first, and then there's the quiz me option, and that's where you earn those mastery points. A pretest number 2 is coming up, I believe for next class, not Tuesday, May 14th, that's a while ago. And you also are now ready to do homework assignment number 2 for Chapter 1. So when you're doing this particular homework, and again, it's going to be done through the MyLab, make sure that you're double checking your dates. We're getting into it now. Things are starting to move along. But when you're doing your homework, it might not come up so much in this particular one, but as much as you possibly can, I would highly recommend use Excel. Use Excel as much as you can. So for example, in your homework, you'll have summation questions. And you will get summation questions that have something like, here are scores, 5, 7, 4, 3, and 1. What is the sum of these scores? And I know that it's probably going to be easy for you to even just look at it and say 7 plus 3, that's 10, that's 9, that's 10, this is 20, right? 10 seconds and you're done. I would highly recommend not to do that. Take the time, put these into Excel, input them there, use the sum formula, because you want to get, again, to the point where you can get that automatically, where you just know, equals sum, open parentheses, highlight it, close parentheses, enter, boom, you're done. So that you can get that speed. So remember, again, on your journey to learn the statistics, make sure that you're waxing on and waxing off in the correct manner, because that's going to make a big impact later on. When you can't do it in your mind, you will have laid down those 20, 30 instances of practice to make sure that it's automatic. All right, so that is it for what I wanted to cover today. A little bonus preview, I guess, trailer for next class as well. I will post these slides later today when I get a chance. If I get a break during one of my office hours, I'll post them up later today. Sorry about the mix-up. We're going to start on the mean next class. And what we'll do right now is we've got about 25 minutes left for practice time. So I would highly recommend use this practice time. Try some of that extra practice Excel sheets if you haven't gotten those done yet. Start up on some of your homework. Give that a shot. And if you're struggling with anything, if anything doesn't make sense to you, if you've tried it a few times and it's still not working out, feel free to call me over. I'll come by and help you out. But other than that, I am done for the day. So if you're having a hard time coming back after Labor Day and you're a little statsed out right now, feel free to call it an easy day, an early day. But for the rest of us, I will be here to help you if you need it during this practice time. Other than that, that's all that I wanted to cover.